Acid-base equilibria problem solving. The question is a student makes 60 milliliter of 1.50 molar sodium hydroxide with 90 milliliters of 0.6 molar HCl. This is acid-base neutralization, sodium hydroxide and HCl. Calculate the mass of NaCl that forms and determine the pH of the resulting solution. Let's write the equation. Sodium hydroxide base plus HCl acid form salt and water. For this reaction, molarity of the sodium hydroxide 1.5 molar, volume is 60 milliliters, convert into liters, divide by 1000, 0.0600 liters. So if we calculate number of moles is equal molarity times volume in liters. Then 1.50 molar times 0.06 liters. Then after you calculate number of moles, you can see it is 0.09 moles. The same way in the right hand side, the right column, HCl. Molarity 0.6 molar, volume is 90 milliliters, convert into liters, divide by 1000, that is 0.090 liters. Number of moles, molarity times volume in liter, 0.6 times 0.09 liter, and 0.05 moles of HCl. Now, just by looking at the balanced chemical equation, sodium hydroxide react with HCl in 1:1 molar ratio. 1 mole of NaOH react with 1 mole of HCl. Then the number of moles, 0.054 is the smallest number. That should be the limiting reactant or completely consumed reactant, the reactant consumed first. With that amount, NaOH required the same amount because molar ratio 1:1. 0.09 moles of NaOH is the excess reactant. After 0.054 amount of NaOH reacted, there are some excess NaOH. Question part 1 is calculate the salt mass. 0.054 moles of NaOH react to produce the same amount of salt, 0.054 moles of NaCl, because molar ratio 1:1. If we know the number of moles of NaCl, mass of the NaCl is equal number of moles multiplied by molar mass of sodium chloride. Molar mass is 58.44, then 0.054 times 58.44. Mass of the NaCl is equal 3.16 grams. Part 2 of the question, we need to determine the pH of the resulting solution. Now we know the excess reactant is NaOH. Sodium hydroxide is strong base. It completely ionized into sodium plus and OH minus. So excess sodium hydroxide moles, 0.09 moles initially available, but reacted amount is 0.054. The excess amount is 0.09 minus 0.054. That is 0.036. Now the equation says 1 mole of NaOH breaks into 1 mole of OH minus. Then 0.036 moles of NaOH breaks into the same amount of OH minus. That is number of moles of OH. But we need concentration of OH minus to determine the pOH. Concentration is moles divided by the total volume. We mix 60 milliliters of NaOH plus 90 milliliters of HCl. Then the total volume is 60 plus 90, 150 milliliters or 0.150 liters. Moles divided by volume in liter is the concentration of OH minus. It is 0.24 molar. If we know OH minus concentration, we can calculate pOH is equal negative log 0.24. That is 0.62. At 25 degrees Celsius, pH plus pOH is equal 14. Then the pH value is 14 minus 0.62. That is 13.38.